Hello and good afternoon to you all. Welcome to Epsilon 2024. I am Ved Chaudhary, Vice Chairperson at IEEE SISGST.
Hello, and I'm Ria, Design Head at IEEE SISGST. We are honored to be your host for fourth edition of our flagship event Epsilon 2024. Here our mission to foster a well-structured, dynamic learning ecosystem while disseminating cut-edge knowledge on theme Tech on Wheels, shaping the future of autonomous vehicles.
We hope preceding two sessions under WI and CS track provided you with significant amount of information. Now it's time for the final session of the day under MTTS tracks, an introduction about Lidar, the eye of autonomous vehicles.
Before we begin, I did like to provide some information for attendees. The exercises and quizzes we have provided for each day of our symposium will put the participants' understanding of the topics covered in each section to the test. Each action is worth a set number of points, and players will be graded on based of them in order to complete on the scoreboard. So, let's begin our most eagerly awaited session by today's introducing today's speaker.
Today, we have Dr. Saurabh Kumar, a senior lead engineer at Qualcomm. He is leading expert in sensor fusion and autonomous vehicle mapping. With a strong background in both academia and industry, he holds a PhD from Changbuk National University and works on integrating LiDAR, IMU cameras, and GPS to tackle complex challenges in perception and localization for autonomous vehicles.
Hello, sir. We are thrilled to have you here, and you
Yeah,
are here and looking forward for this incredible session.
yeah. Thank you, Ria and Ved. Yeah. So let's start. Okay. I'm not wasting much time on introducing myself. Okay. Yeah. So the topic today is lidar, and I will be just first going through the. Okay. So the I will be just introducing the lidar, how it works, and then I will go through the type of lidars because and then the most used lidar is the mechanical lidar. So I will be going the details of that, and then pros and cons of lidar, challenges in data processing because that is the most important part. Yeah, you get the data, but then how to process and what are the challenges, and then what is the need of the sensor fusion, and then fusing the sensor, and I will be taking the questions at the last. Let's go to the first one. Okay, lidar. So so as you can see, so lidar in it's a laser. So lidar works on the laser pulse system. So we first emit the light laser, and then from the objects it's reflected, and then we detect that, and based on that we after reflection and detection we calculate the time of flight, and based on the time of flight, and you guys must be knows that the speed of light is constant, so based on that it calculates the distance. So you can see on the left side of the first on top left, so if you project
Sir,
the
can we
light.
have the slideshow?
I think I'm already doing that. Okay, I will do that again. Yeah. Okay, can you guys see now?
Yeah, yes, sir.
Okay, yeah, so I will go from the start because yeah, without slides is not useful. Okay, so I'm just introducing the lidar. So my topics will be today I will be covering the what is the lidar and how it works and how it is able to detect the distance, and also x and y, and type of lidars used in the industry and as well as academia, and the most used lidar is the mechanical lidar. So I will be going in depth of the mechanical lidar, and I will be also discussing the pros and cons so that you guys can work on the cons to make it pros, and then what are the challenges in software side of data processing of lidar data processing and sensor fusion. So let's go to the first part, which is just basics of lidar. So similar to radar, or so other sensors also, active sensors. uh, so let me give you the active sensor and the passive sensor definition. So active sensor is you send something and you receive. but the passive sensor is you just receive the data. So all like the camera can be a passive sensor, and the active sensors are lidar and radar. In radar also you send the data and receive. So radar uses the radio waves, but here we use laser waves. So we send the so there is a emitter which sends the laser pulse, and the whatever is the object in front, or like
Excuse
in
me,
the,
sir.
yeah.
Can you do full screen?
Okay, yes, yeah. So and in the laser system detect the reflected light, and based on the duration, so that's it detects the time of flight, and the time it took from the going and coming back, and based on that it calculates the distance using the speed of light, because the speed of light is constant. And if you so how but we normally talk about the point cloud, so I'm also defining what is the point cloud. Point cloud is multiple type of data, multiple type of distance measurement of these. So this I explained one of the distance measurement. If you will take multiple, then it will be a point cloud. Okay, so so here there are two type of lidars, 2D and 3D, but I will be mostly going through the 3D lidars because those are the prevalent now and mostly used there in the autonomous vehicle. We use the 3D lidars. So if you will see there are two different terminologies for the lidars. So if you will divide the two type, so one is the based on imaging, how how the image, like how the whole system works or imaging works. So the so one is so there are three types here. One is mechanical lidar. Mechanical lidar, there is a rotator, you can see on the bottom. So there is a rotator which rotates, and based on the rotation it and there is a array of like what column array of sensors, and it transmits and receives there. So based on that it generates the 3D map of whole 360 degree. And there are other type of, because there are mechanical lidars have one problem that they like it they need constant constant servicing. So that's the problem. And all, so that's why some people are coming with the MEMS base, mirror microelectronical base optical phased array. And also like recently Risley prism is also used. Those are called solid state because they don't have to rotate, and they because their structure is such that it can get it can send the data, send the laser lights in all directions, and also receive the laser light in all directions. But these are still very expensive, so mostly it's mechanical lidar is used. And there are flash lidar. Flash lidar is same as, okay, so here till now all the mechanical lidar and scanning lidar, there are they uh, like send or receive only few lasers at one time. Okay, but in flash lidar it's like camera, so it will get you can say that it's the same as global shutter camera. I'm not sure if you guys know the global shutter difference between global shutter and rolling shutter. But rolling shutter is it is like in the camera it scans one row at a time. Okay, it does not generate the whole image at once, but in global shutter it generates the whole image at once. So so the flash lidar is also similar. It will generate whole scene at once. But FOV is also one of the issue with flash lidar. uh, okay, and another is the based on the principle of measurement. So mostly I will be covering the time of flight one. And so time of flight is you send the signal, and you send the signal and get the reflected light, and based on that you get the timing. But if there is another source of light, then there is a signal to noise ratio is decreased. So because of that signal is decreased, so you may get the is like you may get a lot of errors or the miscalculation in miscalculation in case of high external noise, external lighting. So the latest concept came is the FMCW lidars. FMCW lidars are very good with the external lights, as well also they provide the object's velocity. When I will be explaining the pros and cons, you will understand the use of velocity or point velocity very easily. So so let's take the mechanical lidar. So mechanical lidar is like a cylinder. Maybe you have seen like I'm not giving any of the pre-existing lidar system, not showing here because that's like a concern with my company. They did not approve. But if you will see, it's a cylindrical, and maybe you have seen other lidars as well. So they like there is a array or column of the column of laser emitters. So maybe you have seen it is started with 16 beams, and then 60 so there is also 32, 64, and currently it is 128 is quite popular. So 128, so you can see that 128 emitters or the lasers are sending parallelly. So you will get the and then so FOV is decided. So there is a vertical field of view vertically. So they are aligned vertically in a column. So vertical field of view is decided with based on the number of emitters, and but horizontal field of view in case of mechanical lidar is 360. So that's why they can show you everywhere like whole, and they are widely used. And but the problem here is here comes is okay, let me also explain you how they calculate the x and y. So you can see that these are the array of okay column of uh, column of emitters, and then they send the laser, and based on the theta angle, so they get the d value, and then they also calculate the theta, and based on the azimuth and theta they calculate the x and y. So that's why it is able to give you all three directions. Let me okay, so uh, here you can see that so they scan one line at a time, and then whole so 360-degree is divided based on the speed of the mechanical system. It is divided into it is divided, and so it scans one, like let's see if this is a 10 laser scanner, then it will just scan 10 points at one time, and then in the next time it will spend like, but the time difference is quite small. You can but it will be scanning 10 point at a time. So it creates, if the vehicle is moving, it creates a distortion, or you can they call it like in general terms we can call it distortion, or but in lidar term we call the skewing. So this is a bigger problem because you like, and the whole like, so when the data comes, the whole frame is considered as a one sweep. So starting from 0 degree up to and coming back to 360 is whole data, whole one frame, and whole one frame has the undistorted, like because vehicle is also moving, and the mechanical system of the lidar is also moving, and it is rotating. So there is a de-skewing coming. So that is a bigger problem in mechanical lidars. This is one of the field where the active research is working on how in software side how can they de-skew. Let me, and also there are pros and cons of lidars. So the pros I can, okay, so you guys can understand that because it's a active system. So in active system, like in camera it's a passive, so you need external light for the generating the image. But it's because it's an active sensor, so it sends its own light. So it does not matter if there is a light, enough light around or not. Okay, so it can work in low light or no light also, or like lidars were first came with in existence also because of structureless problems, because in camera, if you are tracking or doing the perception or you want to move the robot or autonomous vehicle in an environment where there is no structure, then there are a lot of problems, because there will be because all the points or features are similar. So in those cases, lidar works very well. And sorry, another issue with lidar is good thing with lidar is low privacy issues, because you cannot detect the person or the place easily. So that's why there is no privacy issue, because the resolution is low. And that's also comes as a cons, because field of view is limited. You can see, like, even 128 lidars has only 45-degree of vertical field of view. And resolution is, as you can see here, that it generates it generates 10 points at a time, like those number of points at a time based on the page array. So it will, resolution is also low. And like, but and also another thing you guys can work on is like accuracy of the detection, or the estimation is deeply affected by rain or snow. And this is also one of the research problem we deal, or even many like automakers deal with it. It's rain and snow. There are ways to detect the rain, but still there is not very good way to uh, de-skew or undistort the rain problem. Okay, so this was the I was talking about the whole lidar problem. But now let's come to the how the data is processed, and then what are the problems. So mechanical lidars is most widely used, but then the same problem, de-skewing problem, is really affected a lot. The whole industry is get affected by this. And because of de-skewing, you when you will see the perception or module, they generate the like drift. Perception module or localization module even uh, generate a lot of error. Hello, can you guys hear me? Hello, hello.
Hello, sir, you're audible.
Yeah, are you am I audible?
Yes, yes.
Yeah, okay. So I will continue. So another problem is dynamic objects, because like when vehicle is moving and also the another objects are moving, so it also creates the problem in perception and localization. And obviously when it will create perception and localization problem, the next path planning and the movement planning will be also a problem. Okay. And third, even if the resolution is very low, the point cloud size is also big, so that also creates the problem in data processing. Some algorithms are there where they do the feature detection similar to the image in the like camera image. But those are not very accurate because of their inherent problem of low resolution. And one of the bigger problem maybe you guys like can solve is high vertical drift due to resolution. So because of the low resolution in the vertical direction, and there is a fixed resolution, it's not pixel level, it's like quite high in terms of centimeter. So because of that, the g direction drift is quite high in real. So now let's go. How can we solve these problems? So these problems are solved using the sensor fusion, because different, like as I am giving example, like, so the camera has a camera cannot give the depth, and reason is very simple, because this works in a homogeneous coordinates. And but lidar has low resolution. So the sensor fusion eliminates these problems or also sometimes different sensors are used for uh, like for redundancy, or because if there are multiple sensors in one sensor, like in the night, camera is not very good, but in the structure, like in the places where there are structures or there is enough light, camera is very good, but lidar is not that great. So in those cases it can be also complementaries. So uh, that's how sensor fusion is used. And okay, so sensor fusion is used for two things. One is for getting the better data or eliminating the limitation of each other, and also redundancy. Redundancy is one of the thing uh, is very important in vehicular system. You can see somewhere, like, because here there is no chance for fail. If there is a small failure, there is a big news. And also, uh, let me give you example. If you are detecting a food, if you are detecting how much calories are there in a food, uh, if even if it is telling you by 90% accuracy, it will not matter much. The AI system will not matter much, because and nobody will complain about, or nobody will create fuss about it, because even in the real system it is very hard to detect the how many calories are in a plate. But if the AI algorithm of vehicle will be 99.999% accurate also, there will be questions why not 0.0001, improve 0.0001. So that's the problem. So that's why there is a redundancy. And this by this way, it will increase the efficiency and decrease the error as well. There are multiple sensors we use for for in autonomous vehicle, for which is fused with the lidar. So one is the lidar and also camera. So sometimes we use multiple lidar for fusing the data so that we can get better accuracy. And also camera, and the because camera have the high resolution but smaller field of view, then we can also use multiple camera, as you can see here. So for the lane and road detection and traffic sign, some camera, like we use camera also sometimes. And also radar is also very useful sensor, because it tells you the object's velocity. In environment it also tells object velocity. And that problem is also solved by the frequency modulated lidars. And that's the reason frequency modulated lidars are also getting popular, but they are very expensive. It's still way expensive to even use in the real. Ultrasound sensors are used for multiple type of applications, such as surround view, for surround view, or detecting the if if somebody is lane cross, and these things. And wheel odometry is used for correcting many of things. And one of the most promising thing is V2X as well, which will, because uh, all these other sensors work on the premises where you can visualize other sensors. But V2X is vehicle to vehicle communication, is a wireless communication, which can extend your visual range. Or if I give an example, let's say you are going in a crossroad, and in crossroad you are crossing, and but there is another car coming from the in another side of intersection. You cannot see that. None of the camera or lidar can see, but V2X can visualize that, because there is no need for line of sight. Yeah. And okay. And in the lidar or in the camera, if you see, IMU is the more also one of the more easily available or cheapest sensor available, you used. Okay. But I will be giving a brief introduction on the lidar camera fusion, because other things are quite important, but they they also take time. So I'm just giving example of one. So you can see here, so the camera can give you 2D bounding walks really well. But the problem with the lidar is lidar resolution is bad, so that's sometimes it gives you bounding box quite bigger. But so those things, yeah. Let me just share you with you guys a real example. Okay, so if you guys see here, okay, so this one, this is a real data where you guys can see all these problems whatever I explain. So when you look, when you are doing the perception, these vehicles which are around and moving, they create the problem. And you can see the resolution is not that great for the lidar. Okay, this is the real example, real data. Let me just go through the back. And so, but if you use the lidar and the camera together, so so lidar helps you calculate the depth, and the camera helps you to calculate the exact position. So that in that case you can see the in the end you can get the depth estimation 3D bounding box very accurate. So currently in perception, 3D object detection, segmentation, and like the camera, like camera data is used a lot in the with the lidar, so to get the uh, like holes accurate 3D bounding boxes or 3D projection. And also there are ways to do the, so they first do the 3D bounding box estimation in the lidar, and then they project in the camera, and vice versa. So this way they get the help of each sensor to increase the accuracy. Okay, yeah. So yeah, so I can take questions. I kept the more time for questions so that I I can answer you what is the your problem, you guys think. And also maybe during the question and answer I can give more details.
Yeah, thank you so much, sir, for this insightful session. And I'm sure that the audience must have gained a great idea of understanding all the topics covered here. Now, we would like to ask the audience to submit any questions or doubts in the comment section. Okay, sir, here is one question. Uh, how do LiDAR and camera-based systems complement each other in sensor fusion for autonomous systems?
Yeah. So one of the main thing with the like is depth. The camera, because with the camera it's a 2D image, and based on the 2D image we calculate the 3D position. So but that 3D position, so anywhere in the so anywhere in the homogeneous line, if there is an Euclidean line, if there is any point, that will come to the same position. So that's why the depth is not accurate in with the camera, but lidar gives you depth. So by this way, the whole perception stack as well as localization stack is like enhanced by using both. But there is also okay, one thing I'm just giving a counter here, because this was also very useful thing to think about whenever you design something. uh, okay, nothing comes for free. When you use only lidar, the processing need is quite low. When you use only camera, processing need is quite low. But when you use both together, processing needs are increased exponentially. Okay. So also yeah, so that's the reason we have to like the system, we have to design a system where we does we need it accurately, or does we can modify. Like that's why there are some research going on that okay, we don't need any other sensor and still we can get it, getting the depth of depth mm, okay, estimating depth of the 2D images. So yeah, it's a like so the reason is this, the like, camera on lidar, but uh, wh- why to use it and when to use it is very judicial thing, because processing power, or because in real time processing power is very important, and also memory requirements.
Okay, so here is next question. As you mentioned in a session that LiDAR doesn't need much no light, but wouldn't that oppose the functioning of the module?
No, because it's an active sensor, so it sends its own light, uh, uh, and get it back. Actually, it works best when there is not external light, because external light can like if the sensor detect the light from the external source, obviously it will think that okay, it is coming from the coming from the object.
Okay, so here is an next question, I guess. Uh, can LiDAR be used to check defects in optical fiber cable?
Optical, can you repeat again? uh,
Can LiDAR be used to check defects in optical fiber cable?
Defect in optical fiber cable. That's an interesting thing. Actually, they still check the same way. Yeah, they use some light detection, maybe not exact technology as lidar uses, but they still use the light like light wave, or maybe FM CW waves to check the like optical fiber defect. Yeah, they are used. Maybe not exactly same lidar, but the laser pulses are used there, there as well, because defect actually FMCW can tell you more details of defects than the normal time of flight lidars.
Okay, so here there are many questions really. So here is next question. What are the primary challenges in integrating mechanical lidar in autonomous vehicles?
So the primary challenge, I will list down the like few. Okay, so
Mm-hmm.
one is the like moving vehicle. So when vehicle moves and the so de-skewing is the one of the challenge, and the second challenge is also is the dynamic objects around, because when you do the processing, most of the, like if you will see the ICP assumes, or ICP the iterative closest point algorithm assumes that you have two static scenes, but when other objects are also dynamic, then there is very high chance that the correlation is wrong. So these are the two main issues with the mechanical lidars: dynamic objects and distortion because of the movement.
Okay. Um, yeah. So here Shalini is asking what advances are made to reduce the cost and size of lidar sensors without compromising performance.
Yeah. So one thing is Moore's law, because so Moore's law says that the with every 3 years you get twice processing power. Okay, and also so obviously processing power, and also you get the memory size is reduced by half. So like the memory requirement, the space requirement for the same memory is reduced by half. So those things, and also as the like as I so these things are advancement, and also they reduce the cost. Third thing I will say also, uh, because okay, let me give you an example. Let's say we have spent 100 million on a research project for the creating one lidar. If the demand for the lidar is 10, you obviously you will from the if there are only 10 lidars demand for demand, you have to take out the 100 million that research fund from those 10 sold one. But if the demand is for 1 million, then like the 100 million only $100 per so if the demand is for 1 million, then you need only $100 from
Mm.
each sold lidar. So that's also one of the difference, because the it is widely popular and it is used quite common. So uh, the cost is going down because the research cost is fixed, and the products so per lidar sold, research cost is down. So like
Okay.
all factors, I will say all.
Okay. So, does different environmental conditions affect accuracy of LiDAR?
Yes, yes. I have given one of the challenges I'm also trying to solve is rain and weather. If anybody has some suggestion on that, yeah, you guys can give me. And if you guys want to work on that, yeah, we are also hiring. So okay, so let's see. I'm giving you a rain example. Even the rain example. So in case of rain, the light is an active light, right? So you emit the light and then they will be reflected. But because of rain, the reflection can be before from the not from the object. It can be from the uh, from these and so from the rain droplet, and rain droplet creates a problem. And also there is a deflection because of rain droplet in both side, from the emitter and coming from the object. So those are a bigger problem, and that create a even. And also the in case of snow, in case of snow, because snow is quite porous, the snow texture is quite porous, so it does not deflect or reflect the uh, light well, or like laser lights correctly. So these are the two problems in different countries have different things. Obviously, we hardly have a snow problem in India, other than few states in north.
Mhm. Okay, so here we have next question. What safety standards and regulatory frameworks are being developed or are in place to ensure the responsible use of LiDAR technology in public spaces and commercial applications?
Yeah. So one thing is, lidar is not harmful, and also there is no privacy concern. So one of the things people are shifting from camera based detection of the people, or counting the people, or to or monitoring system, camera based monitoring system, to lidar based monitoring system. Because of lidar, you cannot detect who was there. You can just detect that person is there, but not exactly the person's face. Or many of the many of applications it is. So the privacy is not much concern in lidar, but there are still standard bodies, in and so main thing is, yeah, so there are standard bodies which checks and balance about the frequency used, because it should not be harmful for the people or the animals, uh, yeah, animals body.
Okay,
Maybe
so
I can give the um, yeah, go ahead.
you can say whatever you want to complete. Then I will ask next
No, no,
question.
yeah, I have completed that part. Yeah.
Okay, sure. So here um they are asking how accurate is LiDAR compared to GPS or satellite-based mapping system?
Yeah. Okay, so GPS is satellite based method. So if you will take the normal GPS, its accuracy is around 10 meter. Like I'm not okay. So the average accuracy is 5 to 10 meter. If you will take DGPS, it's around 1 to 5 meter. And if you will take RTK GPS, is less than 1 meter. But if you so this is the, and also frequency. So the GPS gives you data every 1 second, but in vehicle 1 second is if you are running in 30 meter per second. So in like in case of GPS, in if you are taking the GPS data, you will be already past after 1 second. You will be already past 30 meter, so it is not very accurate. And also this whatever accuracy I gave you with the GPS is the is when you can get at least three satellite, uh, like, the direct communication with the three satellite. Okay, but in case of in the places where there is a residential area or the downtown areas where there are tall buildings, you can, so the accuracy degrades really badly, really badly. So you can say 10 times the accuracy values get 10. So that's where these lidar system comes very handy. And lidar's accuracy till now, okay, so I could get 10 centimeter like localization, yeah, in and mapping. Like I could map the system in within 10 centimeter error. And that's my also one of the goal, our team's goal or our community's goal, is that because 10 centimeter is the width of the tire, and for the safe autonomous vehicle running, we need at least 10 centimeter accurate map. Actually goal is 1 centimeter, but till now uh, we were always achieved 10 centimeter. Our goal is 1 centimeter accurate map. So you can see
Okay.
that from the meters to centimeters, that's the
So
difference
here,
between GPS and yeah.
yeah, so here one of our attendees are asking, can you share case studies where LiDAR technology provide a critical advantage in challenging situation?
Yeah. So the one of the place I already told, like okay, in case of downtown or the downtown road or inside the city, lidar helps you much more than the GPS. Like okay, and the other, okay, I will give you in the night. Okay, okay. Let me give you the real time. Did you guys hear there was one crash of Tesla. I'm naming company, which is bad, but yeah, like I should not do that, but I'm like just taking the leverage of answering this question. So Tesla had one crash the Tesla vehicle detected that this is a like there was one trailer in the front, and the trailer had a but the Tesla vehicle detected that it's not trailer, it's a underpass. Okay, underpass, and then it collided with the trailer. So if you okay, so if you use the lidar, it will tell you more. So because they use the radar system, but and there was a hollow system in that. So they have used the lidar in that way, it would have detected the lidar radar data is very sparse, but in case of lidar the resolution is quite enough for detecting these like trailer and or like big trailer, so that collision could have been avoided. Yeah, I'm just giving you a real example.
Okay.
So that
So,
was a good perception issue. And that actually those problems also like reduces the trust
mhm.
of the people, because when these problems happen, the safety regulation authorities as well as the people's trust is down on autonomous vehicles.
Okay. So, light on use of LiDAR in defense technologies. Okay, I guess there are some.
Yeah. So one of the thing I gave you is like detecting the people. Okay. So
Mhm.
it does not matter if the person in the fencing is our person or other person, right? Because nobody should come to the border area, right? So and if like so and the person who is taking the decision to like do something or not should not be based on the assumption that, oh, this is not our, this is somebody else. Okay, so and also not including the people's life. So those things, or people's privacy. So in those cases, that lidar can help you to detect the person or detect the object, but not including the privacy. And
Okay.
that is quite useful in defense. And another thing is, even for um, uh, maybe you guys know that radar is most widely used for defense.
Yeah.
uh, the big the be- the like yeah the most important thing, because why radar is used, because it has the long distance. So if we can make so currently lidar works very good with up to 100 meter or 120 meter. So if we can make the lidar long range, it will be better than radar, because radar is still just tell you velocity of the objects, but it doesn't. And the points are very sparse and quite noisy, and you need multiple readings for the same. So yeah, it can help you, but that issue is still not solved till now.
So, sir, can Lidar be manipulated or exploited? Are there any known vulnerabilities till date, like common problems?
Till now there is okay, you are mm, till now there is not, till now there is not. But yeah, obviously it's also a active field of research that if this can be manipulated, but till now there is no yeah, there is no that it can be manipulated.
Okay. So, attendees here asking any cheaper alternatives for implementing it on large scale.
Can you again ask again?
There are any cheaper alternatives for implementing it on large scale.
Okay. Yeah, actually, yes, 2D lidars and okay, so that's why the sensor fusion also works sometimes. If you get the cheaper lidar, or IMU is one of the best sensor, but which drift are very high, but the frequency is very high, high as well. So yeah, there are cheaper alternative. That's why lidar is not very used. So IMU and camera sometimes work better than lidar in many of the. If there is enough light available, IMU and camera works better than the lidar. IMU gives you depth, and the camera give you texture and the environment and very well. But those only texture is a limitation. Yeah, there are cheaper alternative.
Our attendee is very curious about.
So
Can't real
I will
time.
suggest, if you guys are
Yeah.
interested in autonomous system, I will suggest you to read IMU. IMU is the most promising sensor. It is available in phone as well, and MEMS based system, and you will be amazed that how much useful it is, and it is used everywhere in the perception and localization, even path
Thank you,
planning.
sir. Thank you, sir. So here, one of our attendees is very curious about real time instead of LiDAR,
Instead of lidar, 3D
yeah,
mapping so is okay,
as
yeah,
it can also
real
give
time.
info about incoming potholes.
Hmm. Yeah. So real-time 3D mapping can be done without LiDAR. Yes, with camera and IMU, or multiple camera. But the limitation is uh, yeah, limitation is light and texture. But in vehicular, daytime vehicular use cases, yes, it can be done easily.
Okay. So, can you shed some light on cyber electromagnetic operations and how they manipulate radar in defense sector?
Oh yeah. So okay. So these are the these are very like uh, okay. So what happens? They okay. So radars, if you will see, radars are very sensitive to the metals. Okay, and also though there are some so if you will see the radar testing and these things, they use the one of the triangular triangular type of object to for and its accuracy is quite high. So if you will have if the the if there are around those triangular metal objects, then radar is very susceptible. So yeah, they use that system. And also uh, and on that, maybe I don't have much because research knowledge, like maybe in-depth research knowledge, but yeah, those they use that.
So that's the end of a Q&A session. That was really great. I hope that all doubts were cleared. Thank you, sir, for incredible session and addressing the educating the attendees with the same informative discussion. We are grateful to you, sir, and we would like to present you the token of gratitude. Thank you for being part of Epsilon 2024.
Thank you guys, and hope you guys got some insight. And if you guys have any doubt, you can reach to me by address like that. Okay, and yeah, have a nice day, guys. Bye bye.
Thank you, sir.
Yes, sir.
All right, everyone, buckle up because it's time for quiz. You have 10 minutes to complete this quiz, the link of which is available in YouTube live chat bar. So please check.
Thank you for being such a great audience. To get the input, we have included a feedback form in the chat box for all the three sessions conducted today. Do join tomorrow for hands-on workshop of CS, MTTS, and WI.
With that, we came to an end of day 1 of Epsilon 2024 and learned a lot today. We also wished you a best of luck for all your future endeavors.